Hey everyone, in this video I'm going to give you an overview of the setup on my MyFlyDream Mini Crosswind. I'm going to give you a little bit of details on the build. We will also look at my iNav settings and then some footage from the Maiden Flight. This video did end up being a bit longer than I intended, but don't let that put you off. If you want to hover over the timeline below, you can skip to the section that interests you. First of all, when this came, the first thing I thought was it was really well packed. I'll put a picture on the screen of the packaging that it came in, and you get a lot of parts. So here is all the foam parts that you get, and this is all the plastic parts, and then you get all this hardware here. Now unfortunately with my kit I was missing half a nacelle, the larger bottom part for one of them, and I was also missing one of my wing connectors. I did have 4 parts, but they'd sent me an incorrect one, so one of the pieces I had 2 of, even though all 4 should have been unique. MyFlyDream customer support was a little bit awkward to say the least, but eventually I got through to them and they did send the parts I needed, and when they did, it was with next day delivery from China. So that was pretty impressive. So not a bad result in the end, but a shame that I had to go through that. Okay, to start with, this setup is running 6S, so I have a Turnigy 10 amp LiPo in there, and the motors I'm running are LD Power 2814 510 kV with 9 by 7.5 props, so they are counter rotating motors. So this one from behind is the clockwise motor, and then the one with the black nut is the anti-clockwise, and the only physical difference in the motors is the direction of the thread, and with the prop nuts on the front, just so that when they're spinning they're trying to tighten the nut rather than loosen it. Okay, I'm running a Dragon Link receiver out on the left wing on 433 megahertz, and then under here I have a Matek 1.3 gigahertz video transmitter. And under here, buried in the wing, I have the True RC Singularity side feed. That's my kind of favourite setup at the moment, so you can bury them in there and not even visible. So they're nice and aerodynamic there. At the front here, I have a Cadux Ratel in this kind of panning device. We'll talk a little bit more about the pan shortly and the setup on that. I have a Matek digital airspeed sensor installed on this one. Inside I have a Matek F765 flight controller running iNav, and also I have a little GPS receiver in this bay here. So the original design from the manufacturer was that actually this would be for a GPS receiver, and this would be for your control receiver, specifically the MyFlyDream R-Link. But because I have put my UHF in the wing, this was going to go unused, so I put my GPS in there just to save wiring. Really, it's just so much closer to the flight controller. And then up the back here I've installed a Toothless 2 in the tail, and obviously because the Matek flight controller has a built-in video switcher, it's just plugged straight in, and it just gives a nice alternative view while you're flying. I'm running some Emax servos for the control, one in the rudder, one on the elevator, and then one for each of the ailerons. Now this plane actually is designed so that if you want to, you can run dual servo on the elevator. You can see mine just in here, and it's linked up here. But I haven't got one in this side. I just decided not to do it in this build. And then there is actually a kind of silver bar, which you might be able to make out there, which basically links this side to this one. And obviously it makes it so that it controls both surfaces with one servo, and you wouldn't want to fit that if you were going to put 2 servos in. Okay, the last thing to mention about the build is that I'm running 2 30 amp ESCs. They are Hobby Wing Platinum Pros, and they don't have any BECs in them. So next we'll just talk about the things I really like about this plane and why I chose this over some of the other big twins on the market at the moment. So firstly, one of the things I really like about this is these wing connectors. I think they're really good. First of all, because there's just a couple of buttons on the bottom. What you do is you just push those buttons in and the entire wing pops off. So it makes it really nice and easy to transport. The other thing is that inside these wings you have the electronics connectors, so you don't need to worry about plugging in servo cables or ESC cables. Once you plug the wing in, that's it, all your electronics are linked. The great thing about these as well is the connectors provision for more than the standard gear. So you might find some of these models come with the 2 main connectors for your ESCs, and then you'll have another 6 pins for 2 servo cables, which would be 1 to your ESC and 1 to your servo out the wing. But these actually have 9 pins, which is really good because it allows you to easily put gear out on the wing, and that's why I've done that on this model. So similarly at the back here, these tail pieces are removable. So there's just on the top and bottom, there's just kind of these sliding latches. You just slide them both forward. You can grab them both with one hand like this, and then you can just slide that off. Basically, these parts here are the parts that move and stay there. When you put these on, these slot inside of these. Another thing I really like about this plane is the plastic hinges that come with it for the control surfaces. So the ones on the rudder and on the elevator, which are on the underside, I do like a lot more than the ones on the ailerons, but they still do the job really well. They were just a bit more awkward to fit, and they kind of came out the other side of the control surface. But still, they're pretty good. Another thing is, if we look under here, the servos actually come with these nice holders, so you don't have to glue them into the plane. You glue the base in, and then you screw a cap on top. And obviously with the kit, all of the linkage, servo horns, seems pretty good quality, and it's all included with the kit. If we look inside this plane, it has a monstrous amount of space. So this is the plane fully loaded, ready to go. It's already got the 10 amp 6S in the front there, and obviously there's my flight controller. This is just the cable to connect. So you look at all that space there, it's kind of mad. I mean, there's so much space here that you can actually fit a second one of these 10 amp 6S, so you could run 20 amp if you want to. This does, it brings the weight up quite a lot obviously, but it's still under the recommended all-up weight from My Fly Dream of 5 kilograms. I think it was close, it was around 4.5 kilograms with 20 amp of 6S. I won't be running it like that, I just kind of did it just for the fun really, just to have a look. But yeah, it stays in the air plenty of time with just 10 amps, so I've no need to run 20 in this. And we'll take a look just in here. So the canopy's a nice design as well. You can see it kind of has these little latches which go into these holes here. And that clip just locks onto the carbon sleeve inside there, so that works pretty well. And another small thing that I really like is this ply tray at the bottom for the battery that you glue in. It's got a nice little scale with numbers on it. So a couple of other small things that are quite nice. This nose is separate from the main body, and it's really nice and easy to install a pitot tube because there is already a hole through the nose as standard. It's nice that they do provision spaces for your GPS and your receiver, even though I haven't used them for the intended purposes. And yeah, I guess why did I choose this one now over the other big twins on the market? And that includes its big brother, the Pro version, which is a 1900 wingspan. Firstly, the wing connectors. The wing connectors allow, well, they have 9 pins, so they allow for you to put extra gear out on the wing, which the Pro version doesn't have. And it also seems that a lot of the big twins don't have a proper FPV canopy. Obviously you can cut into the standard one, but it's just, I do like that this comes with one purpose-built as standard. And in general, I just like the look over some of the other models, like the Mini Goose and the Believer. Okay, so next I'll try and give a brief overview of the build without going into too much detail. Just remember that the two halves of the fuselage are separate. You do have to glue them together at some point. So what I did first was I got to work on the wing connectors. So there is hardware to install on all of them. You can see on the tail, you have to install these. There's a little spring inside here as well for the latching system. Something similar on the main wings. On the tail here, there is a couple of items to install. And this is the one that's kind of a bit more important, because this is the one that you have to install the parts before you glue this in place on the fuselage. So behind here there are two kind of metal plates that just go around here, and that's for these kind of latches to grip onto. So everything else you could have glued these all onto the wing and tail and then installed the hardware afterwards, but with this one you have to make sure you do it first. So once I'd got all of those in place, I then glued the two halves of the fuselage together. There's a couple of important things while you're doing that. Firstly, there are two big spar sleeves here for the main carbon fibre spars in the wings. They have to be in place when you put the two halves together. And then also in the tail here, you have to make sure there's a little carbon spar that goes in here, like a sleeve. That has to be in when you glue the halves together if you've already got these glued to the plane. And if you're doing a single elevator servo setup, then there is a silver bar which you can see which goes through from this one to this one, linking the two. Now you have to make sure that that is in place and it slots into these two, and that these two are aligned at the time that you put the two halves together. Okay, so after that, I started to work on the electronics in the wing. In fact, just to mention as well that all of the carbon fibre spars in the wing, in the rudder, and in the tail, these are all pre-installed, so you don't have to put them in at all or mess around with any glue. So I went about putting the electronics in the wing, obviously glued the holder in for the servo, fitted that in, and I cut a nice hole out here for my Dragon Link, and then made this channel for my wiring. At this point I haven't fitted the motor nacelles. This is the tool that I use for, it kind of melts the foam rather than cutting it, but it is called a foam cutter. But these are really handy. I'll put a link to that in the description. So once I had got this installed, the cabling, the next thing I did was I decided to laminate the nacelles, the two halves, while they were off the wing. So I started with the smaller half there and then laminated this. I thought that would be easier than trying to laminate when they were on the plane, and also I thought it would make it easier to laminate the wing without that in place. Also, just to mention that on this build I have laminated the wings, nacelles, and just a piece of the belly on the plane, but nothing else. So what I did was, once I got the main wing laminated, I held the nacelle up against the wing without gluing it in place, and I kind of cut around it. And then what I did was I tore the piece of laminate off where foam was going to touch foam where these were glued in place. So it left a nice rough surface. And I glued this on with E6000. And in fact, good to mention that I did glue the two halves of the fuse together with E6000 as well. My little tip with E6000 is that it's excellent glue. It's flexible, you can paint it, it doesn't weigh much. But one of the problems is that it takes a little bit of time to set or dry. So what I do is anything that kind of needs holding together, I just dab a little bit of hot glue here and there, just to get that instant hold, and then that allows the E6000 to do its job while it's held in place nicely. So once I got that done, it was then time to make sure the motor and the EC were hooked up and that the rotation was correct before I glued this all in place. And then I got all the electronic cables coming out here ready to solder. So one point about this build is you can't just do all the soldering for the electronics onto this connector on the back and then put everything in and just slide the connector in, because the connector has to go in from this side. So what you have to do is you have to put some cables, you have to solder some cables onto the connector coming out to say here. And then what you have to do is leave all of these cables kind of loose out to around here, maybe with just a bit of overlap so that you don't make it too tight. And then what you have to do is you have to solder all the cables here over the wing, which is a bit of a pain. I don't really like soldering over the foam that close, and also, you know, you've got to try and get it so that it's long enough that you're not going to make it too hard to solder, but it also isn't so long that you know, you get too much cable in there. But the good thing is there's a bit of space in the nacelle there, so you can actually just pull a bit of that through. And then what I've done is I've taped it over with a bit of this reinforced fiberglass tape, and the little screw you'll see there is where the CG is on this plane, so it's 80mm from the leading edge of the wing. Next, I glued in the vertical stabilizer. There is a hole on the top of the fuselage there, just in line with this channel, and that's where you can slot your servo cable through. And obviously what I did as well was I cut out a little piece of foam here for this really small camera, and again cut a channel right down here to join this one for the FPV camera cable. And then obviously inside here I've got extensions for the servo, the camera, and also the elevator servo coming up to the autopilot. And if we look around the other side, I'll show you where I installed the servo. So there's a nice slot in there for it, and then you link it up to this rear part here. Okay, so out on the other wing it was the same procedure as the other wing. The only difference is on this one I have the Matek 1G3 video transmitter, and under here, which you can't see it, you can kind of probably just about make it out, that's where I've got my side feed antenna. I'll pop a picture up on the screen so you can see that without it being covered in the orange vinyl. Okay, and then after that, really all that's left is to just glue a few other parts in. You know, you glue this holder in, glue the GPS cover over. The only thing with this actually is that once you glue that on, that, you know, it is stuck on, whereas everything else seems really easy to remove. Like this is screwed on with 3 screws, so that's easy to pop open, whereas that seems a bit more permanent. And then in here I did all the wiring. There are some channels along here. It started really tidy, it started to get a bit more messy as more cables were added. It's still not too bad. And obviously linked everything up to my flight controller in there. What I've done is I've used XT60 connectors on the cables that go from the flight controller to the wing connectors for the ESCs, so that if I do want to at any point, the flight controller is completely removable. And then coming off the flight controller with the large cable, I've got an XT90 because that's what my 6L lipos are running. All of this is open up at the bottom while you're building it. So you get 2 of these bottom bay hatches. One of them is designed for landing gear, which is this one here that's still in the packet. I haven't used it. So you can see it's got the cutout for wheels. And this one's just designed for belly landing, so that's the one I've fitted in there. And that was again glued in with the 6000. And if I just turn this on its side, what I've done is you can see I've laminated the bottom of this and just come up a bit round here just to cover the join of that bottom bay there, even though there's nothing heavy sat on it, but just to give it that extra bit of hold. And then there is another little hatch here, which is really the only reason that was useful to have a cutout here, was to access all the extension cables here where they're kind of joining. And I just wedged that in because it was quite tight when I put it in, and then just laminated over it. So if I really do need to get access to the extension cables in here at any point, I can just cut round that and pop it back out. Okay, the Matek digital speed sensor is just in here. It comes with all the hardware to install it and the cable, so that was pretty simple. Just had to make an extension to make it reach my flight controller. Drops a little glue on the pitot tube to hold it in the front there. And then we move on to this last piece. Last but definitely not least is this 3D printed canopy and pan system at the front. So this allows me to pan around 270 degrees and see the tail in both directions just using a standard 9-gram 180 degree servo with a small modification using some resistors, which I'll talk about in a few minutes. So this is designed by a guy called Josh, known online as Bandit FPV. And this came about because we were both building the Mini Crosswind at the same time. And I sent him my mock-up of this canopy base with a slot for a GWS 360 servo, and he basically had a much better idea, and that was to be able to use a much lighter, smaller servo but build this 3D printed support device here, similar to the Mark QV setup, but this doesn't require much hardware like his did. It's all 3D printed and then just some M3 screws to go with it. So it's actually made up of 5 pieces. The first one is a PLA canopy here, which has a hole in the middle. And then the next piece is a servo mount base, which again is printed in PLA, and that screws into the canopy here. And then the servo screws into that piece so it holds the servo in place. The first advantage of that is if your servo dies, you can just pop that out and replace it. The second advantage is the kit actually comes with this aero canopy for, I think it's designed for mapping basically. So what you could do is if you want to go on a long range mission and really be efficient, you could just pop that on. Next piece is you have a servo coupler, which basically mounts onto the servo horn. You have this coupler bearing here, which kind of gives the servo support. So if when the weight of the camera starts to tip to the side, this brace kind of takes the weight rather than it being loaded onto the servo. Then the last piece of this is a TPU part. The top part here is designed to hold a micro camera, so I've got the Caddx Ratel in here. Again, this is friction fit. I've just pushed it in. It doesn't need any glue or anything. And then this part is to hold my DJI camera. Okay, so here's a quick clip of the pan with my phone so that you can see it with the HD camera installed. I've also got the torch on so you can see all the parts in there. So you can see the white part is actually the standard servo horn that comes with the servo, and the part on top of it is the coupler that goes up, and there is a screw that goes in the side of this TPU part which grips onto the coupler. So big thanks to Josh for designing that part. It works really well, and I've actually got this set up with my head tracker, and it just really makes the experience even more enjoyable. So just going back a step, the servo in there is a 180 degree servo. You can use the one from Banggood, which I've got in here, or I believe there's one from Hobby King, which also works really well. I'll put the links in the description. And basically what you have to do is you have to pop the bottom off the servo. Inside there are 3 cables coming out. What you do is you cut the 2 outer cables, and then you solder in line on these 2 cables a 2.2K resistor on each of them, and then you put it all back together. The next thing you have to do is you have to adjust the weight in your transmitter for that pan, because if you leave it set to a weight of 100, once it reaches a certain point, the servo will actually just continuously spin 360 degrees. So I think I had to drop mine down to about 80%, but you can just mess with that until you get to the point where it's not spinning in 360 degrees continuous. One tip is to make sure that you haven't got your camera connected with a cable in while you're testing that, because it's going to get tangled and messy pretty quickly. Okay, so the last thing I did with this build is I cut a small channel in the canopy here to make way for the FPV camera cable. And the reason I did that is just so that it doesn't get lifted up by the cable and kind of act as an air scoop. And that cable is now absolutely fine when this pans all the way around. Okay, so I think that's it for the build overview. I hope that wasn't too long. Next we'll just take a quick look at my iNav configurator settings in my office. Okay, so I only want to do a couple of minutes in iNav quickly, just to kind of talk you through the routine that I go through setting up a new model. Basically what I do is I copy one of my previous models' diff all files and paste it into the CLI. In this case I use my ZCon. And then I'll do the same with my Tyrannus. I'll just kind of copy the model and paste it in, and I'll just make a few edits from there basically. I will include the diff file, a link to that in my video description so you can see all of my settings. But I'll just quickly go through the settings I changed on this model when updating it from the ZCon. So first of all, I go into the mixer and I changed it to an airplane because the ZCon is a flying wing. Now I could have chosen an airplane with differential thrust, but I'm not really that interested in doing that on this model. Okay, so the next thing I did was set up the configuration for the pan servo. Basically what I've done is I've added a new servo in here. 1 to 5 is already taken, so I added servo number 6, and what I did was set it to RC channel 6. So obviously in my TX I would have then set up the pan servo for this channel. And then all you need to do is, you can see that servo number 6 here is in output S7, so you simply plug your pan servo into slot 7 on your flight controller. Next I went into configuration and just made a few changes here. So because I'm using a digital airspeed sensor, I selected the MS4525 here. Made a few changes to match my setup, so I'm using a 10 amp LiPo, and also to change the name of the model. In advanced tuning, after the Maiden took place, I did come in here and change these values to be slightly higher. And also I increased this pitch to throttle ratio because as the plane was climbing in return to home, I noticed it was struggling a little bit and looking like it could stall. So I just upped this just to try and prevent that. Next onto my modes tab, because I have the second camera, I had to add this in. So channel 10, I have a switch. Basically with it in this state here, this would be the first camera, and once you flick the switch, so that it moves to this area here, that activates the second camera. Next I went into the OSD and basically I left my standard layout, which I really like, but I did add the airspeed in here. The only other settings I changed using the CLI tab were some relating to the launch settings, which you can see in my diff file, but apart from that I didn't make any more changes to the config, so now it's time to head out to the field and take a look at some footage from the Maiden. This plane is quite heavy at 3.25 kilograms, and I'm going to be launching this by myself, so I needed 2 hands, so I decided to trust auto launch for the Maiden. And I was a little bit nervous about this, so I did run back to the transmitter just in case. You'll notice I did use the shake technique. I just wanted to make sure that it was going to activate the motors on the first go, and I'll change the settings and won't need to do the shake from now on. Here is that launch again from on board the plane, and just listen to the sound of that twin. During the launch it pulls a maximum of 21 amps. And this is actually the maximum you'll see from this plane at any point during the flight. It didn't take long for me to realise that the airspeed sensor was giving an inaccurate reading on this flight. The airspeed was always lower than the ground speed, even if I was going against the wind. I found a setting called pitot scale, which I do need to play with just to try and get that more accurate. For the next 10 seconds you'll see I'm using around 4 or 5 amps, and it's cruising quite nicely at, I'll probably say, an average of around 70 kilometers per hour. So I'm just about to test the pan for the first time, and there's something pretty cool about these twin engine planes, looking out over the wing and seeing that motor and prop spinning. So I'm just testing the return to home mode while also playing with the pan at the same time. Return to home is working pretty well. Based on this it does bank quite sharply sometimes, so I'll just reduce the max bank angle in the configurator for the next flight. What a great day for a Maiden, look at that view. Now I'm just going to switch over to my second FPV camera on the tail. Pretty cool alternative view, it's nice having the plane in shot, I do like this. This reminds me I still need to turn that OSD off on that camera. Time for some full throttle flying. So here you can see my throttle is at 100%, and I'd say flying level this will average around 110 kilometers per hour, pulling 14 amps, which I think is pretty impressive stats for this airframe, and I'm really happy with that. When flying fast and low like this, I did realise that it's quite sensitive on the pitch, so I do need to reduce the rates and maybe increase the expo. And now at this point here, this is where I'm going to return to home, and this is what made me think that the pitch to throttle ratio needs to be increased, as I felt like it lost speed pretty quickly here trying to increase the altitude, and it looked like it was going to stall. So I have since increased the cruise throttle, so that might not be an issue anymore, but again the pitch to throttle ratio was increased just to make sure. So I haven't been trying to fly efficiently on this. I've been doing lots of messing around and testing wide open throttle, climbing, and I've only used 4 of my 10 amps. I've covered 42 kilometers in 35 minutes, and I'm just having to land because I've run out of time on this day. I estimate that if you're trying to fly efficiently, you could probably stay in the air for 1.5 to 2 hours with this airframe on this setup, but I'm also going to guess that my flights are going to be more like an hour on a higher cruise throttle. At this point I'm going to leave you with a couple of minutes of footage from the second flight with this plane. The launch was a little bit dodgy because my hands were soaking wet and so was the plane, so it was quite slippy. But apart from that, it was quite relaxing and a nice flight down the river with a good test of the Maytech VTX for the first time. I appreciate this has been quite a long video, so thanks for watching. Please give me any feedback in the comments, and please remember to hit like or dislike.